All right, so 3, 2, we talked about the special angles when two parallel lines are cut by a transversal. Alternate interior angles are what? And if the lines are parallel, what's true about their measures? Congruent. Alternate exterior. Same side interior. Supplementary and corresponding. Congruent. Okay? So when you look at this, it says what theorem justifies each statement. You could have given the name, okay, but you can also just have written it out. So angles 3 and 6 are called what? Alternate interior. So you can write if lines parallel, alternate exterior, congruent. Or you can write alternate exterior angles theorem. Either way. It's right about that time, folks. Just about to start the week. Right? It's like the weekend. Here's your rain. All right, 2, 4, and 6 would be what? Consecutive interior, same side interior, okay? Again, I could write it as if lines parallel, consecutive, interior, supplementary. Or same side SS, interior, supplementary. Or you can call it consecutive interior angles, and this is the postulate, right? No, corresponding is postulate. 3, if 2 is 115, find the measure of angle 7. So if this is 115, what's the relationship between 2 and 7? Alternate exterior, and if the lines are parallel, alternate exterior angles are congruent. So this is 115. Questions on any of those? Okay, number 4 says to find the values of x and y. So the top and the bottom lines are the ones that are parallel here. So how could I solve for, let's start with x. Do 6x, do these and these have a relationship? What are they? Same side interior, and if they're same side interior, they're supplementary. So 6x plus 30 plus, God bless you, 2x plus 10 would equal 180. 8x plus 40 would equal 180. Subtract the 40. 8x would equal 140. And this would go 140 over 8, which is 70 over 4, 35 over 2, or 17.5. Any of those answers work. Well, not any of them. The 35 over 2 or the 17.5 works. Now, what kind of relationship can I form for y? If y is here, y is along this transversal, right? So like I said yesterday, sometimes you've got to ignore some lines to see the other relationships going on. So this is alternate interior with this. Everybody see that? So what's true about y plus 10 and 2x plus 10? They're equal. Y plus 10, 2x plus 10, and now we know what x is. So y plus 10 would equal 35 plus 10, y plus 10 would equal 45, and y would equal 35. So this is x, and that one's y. Okay, in 5, it says the figure shows a plant trellis. If the measure of angle 1 is 82, so this is 82, find the measure of 2. 82. Okay, so they can make parallel lines with just about any figure. That's the idea behind this. The plant trellis would be parallel lines. They're marked by those little arrows, and then those would be corresponding, which makes them congruent. Yep. Sure, just grab the pass. Questions on the warm-up overall? Questions on 3-2 before I get into homework? Okay. So this one says, the perpendicular transversal theorem states that if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. Write a proof of the perpendicular transversal theorem. So you're proving that if it's perpendicular to one, it'd be perpendicular to the other, and they give you that T is perpendicular to R, and R is parallel to S. So both of those are marked in here. So obviously I'm going to start where? With the given. So T is perpendicular to R, and I can write them both in one because it's both the same reason. R is perpendicular to S. This is given. Parallel to S, sorry. Okay, and I want to get that T is perpendicular to S. So how would I prove that something is perpendicular? How do I know it's perpendicular? What does perpendicular mean? There has to be 90 degrees. So I need to prove that angle 2 is 90 degrees, right? That's got to be where I would get to in order to prove that that's perpendicular. So how could I do that? So what's that little box? Okay, but it's not there. So how do I get it there? Huh? No, you can't do it with a protractor. You can, but that's not what it wants you to do. Emily?
You can prove that 1 and 2 are equal to each other because of the corresponding theorem.
Okay, so I know 1 and 2 are equal, so you can write that now, or you can wait and you can do that one later. Angle 1 and angle 2 are congruent, because if the lines parallel, corresponding angles congruent, or corresponding angles postulate. Okay, so now I know this is congruent to this. Now what do I have to know about angle 1? Evan?
You can know that it's 90 degrees.
How do you know that?
Because it's 90 degree angle.
So I have to say first that angle 1 plus whatever this angle is here, right? Which is not marked. Let's call this angle 3. Angle 3 equal 180 degrees, right? And that's linear pair postulate. So then angle 1 plus 90 would equal 180 degrees. And that's, oh, I would have had to say that. Sorry, hang on. I have to say angle 3 equals 90 degrees. And that's the definition of perpendicular. Now I can say angle 1 plus 90 equals 180. And that's substitution. And then I can say angle 1 equals 90. And that's subtraction. And then if angle 1 equals 90 and angle 2 equals angle 1, then angle 2 equals 90. And that's substitution. And then if angle 2 equals 90, then T is perpendicular to S, and that's definition of perpendicular. You can actually now go from 1 to 8 because of the perpendicular transversal theorem, right? This is proving the perpendicular transversal. God is mad at me for doing a proof. I'm sorry, okay? The perpendicular transversal theorem says if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. So on a test, you can go 1 to 8. 1, T is perpendicular to R is parallel to S, given. 8, T is perpendicular to S, reason, and it's called the perpendicular transversal theorem, but it says if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other one also. Yep.
Are there going to be proofs on the quiz?
On the quiz, yeah, you're probably going to get one. Oh, I love it when you whine. It makes me want to do it more. I love it when you cheer. It makes me want to do it more. Yeah. Section 3 is called proving lines are parallel. So you're going to learn different methods to proving lines are parallel. Okay? They're not all proofs, but there are going to be proofs. No, because we say so does not work. All right, so this is a postulate, okay? So this is now the reverse of what we did in 3-2. In 3-2, we said if the lines were parallel, then corresponding are congruent, alternate interior are congruent, alternate exterior are congruent, and same side interior are supplementary. Now we're flip-flopping it. We're using the converses. And we're saying if the lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So we are literally using the converse of each of the theorems and postulates we learned in 3.2. So if angle 2 equals angle 6, then J is parallel to K, and your reason would be the corresponding angles converse postulate. So you've got to know the difference between the original and the converse. The converse is going to prove that they're parallel. The original would have said that if they're parallel, then the angles are congruent. Okay, the alternate interior angles and alternate exterior angle converse both start exactly the same way. If two lines are cut by a transversal, and for alternate interior, then we say, and alternate interior angles are congruent, then the lines are parallel. And then alternate exterior says if the two lines are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. So again, these are the converses to what we learned yesterday. So for the first one, alternate interior angles. Give me a pair of alternate interior angles from this diagram. Emily. 3 and 6. So if 3 was congruent to angle 6, then P would be parallel to Q. Okay, how about exterior? Give me a pair of exterior angles. 2 and 8. If angle 2 was congruent to angle 8, then P would be parallel to Q. So obviously they're not going to be that easy. There may be like a couple more steps in there. That would be a, given and approved statement. But it would be along those lines. Okay, and then the consecutive interior angles converse. This one says if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So remember, consecutive or same side interior is supplementary. So if angle 2 and angle 3 were supplementary, then M is parallel to N. Okay, transitive property of parallel lines. So if two lines are parallel to the same line, then they are parallel to each other. So this would look something like this. If J is parallel to K and K is parallel to L, then what? Good. J is parallel to L. That's the transitive property of parallel lines. So not just transitive property, okay, because transitive property applies to variables and segments and lines. We add on there of parallel lines. Okay, so this slide just sums it all up. These are the 5 ways to prove that lines are parallel. Okay, the first is that a pair of corresponding angles are congruent. The second, alternate interior angles are congruent. The third, same side interior or consecutive interior, same thing, are supplementary. 2 lines are perpendicular to a third line, and 2 lines are parallel to a third line. So those are the 5 ways that you can prove that 2 lines are parallel. All right, so looking at this diagram, it says which segments are parallel. So here's some application, okay? There's no, right off the bat, matching measurements, right? Everybody sees that, right? There's no 24 that matches that first one. There's only 136, there's only 122, there's only 138. What happens when you add 24 and 36? You get 60. What happens when you add 22 and 38? You get 60. So this is not so hard because there's only one transversal, but once you start getting a little bit more complicated, it's a little hard to identify angles and lines. My advice is draw out what connects that angle, and then there's going to be one side in common. That one side is your transversal. And the other two lines are the parallel ones. So in this case, I would say AC is parallel to BE. So I told you it yesterday, but there's going to be a lot of turning pages and drawing on diagrams and color coding. I'll leave out colored pencils for this quiz and test, okay? Because you might need them. Sometimes it's hard to visualize this stuff. Okay, this is saying what value of x makes AB parallel to CD. So again, these would be the parallel lines, AB and CD. The line that connects them would be BD. That would be my transversal. So I have a little right angle here, which tells you that what would have to be true about this angle here? Have to add up to 90 degrees. And if part of it is 40, then what is my x? 50 degrees. And how would I have shown that those were parallel if I knew that they were both 90? There's two ways. But what would be my reason for showing that they're parallel? Nick. Try it. Nobody ever died from trying. All right. So I've got corresponding, right? Those are both 90 degrees, which means they're both congruent, and then if corresponding angles are congruent, then the lines are parallel. What's the other way? There's only 5 to choose from. We already used one. What about that little box makes those lines special? They're right angles. And what's it called when two lines meet at a right angle? Perpendicular. And look back on your 5 options. Do you see the word perpendicular? Yes. What does it say?
In a plane,
Mm-hmm.
so that both lines are perpendicular to a third line. That one?
Yep. So are those two lines perpendicular to a third line? The same line? Yes. So that's your other way. Okay. So you could show that they're both 90, and if they're both 90, they're equal. And you can also have said that they're both perpendicular to the same line. So 2 ways to do the same proof. Okay, this one says find the value of x that makes J parallel to K and L parallel to T. So here we've got 2 sets of parallel lines, and this is where it gets a little bit trickier, okay? So let's start with x, for example, okay? X is here, right? Does x have any relationship with 2y? Is there a transversal that connects them? There is no transversal that connects 3x and 2y. Do you see that? This one would be here, and this one would be here. None of those lines are shared. Does that make sense? So there's no direct relationship between 3x and 2y. But 3x and 60 both share that line and that transversal. Well, that 2 lines. Whoops-a-daisy. So here and here are both connected. This line, which would be the transversal, and these would be the parallel lines that we're trying to prove. So what's the relationship between 3x and 60? They're corresponding, and if they're corresponding, in order for these to be parallel, what would have to be true? It'd have to be congruent. So 3x would have to equal 60, and x would have to equal 20. And now, look at 60 and 2y. What are these? Alternate interior. So in order for those lines to be parallel, what has to be true about the alternate interior angles? Congruent. So 2y would have to equal 60, and y would equal 30. So you might have to break them apart. You might even have to like cover up one of the transversals because it might not apply to the other one. Questions on that one? Okay, this says, how can you tell whether the sides of the pattern are parallel in the photo of the diamondback snake? I hate snakes, by the way. It's brutal. Okay, so if I were to zoom in on it, you can see there's little red lines, right? There's this one, and they've marked this angle with this angle. So what's it implying? How would I know that those are parallel? Good. So if the alternate interior angles are congruent, then the lines would be parallel.